Hello everyone, thanks for stopping in. Today we're going to talk about section 6.1 for Math 120. We're going to start off with a boatload of definitions. So let's take a look here at some of these definitions. The first is a constant, which is a fixed, unchanging value. It's always the same number. Some examples, the number 2, maybe negative 3/7. Always the same number, right? Pi, it's always 3.141592, so on and so forth. It's infinitely long, but it's always the same. Maybe another example, the square root of 2. Once again, it's a infinite decimal, right? But it's always the same decimal. These are always the same value. On the other hand, a variable is a letter used to represent an unknown value. Some examples, probably the most common, the letter X. We love the letter X in math, right? We see the letter X all the time. It's a letter used to represent an unknown value. Maybe we have A, or N, or the Greek letter alpha. Or maybe, any letter you want to use. It can be a Greek letter. Sometimes we'll see Greek letters. Maybe it's the letter mu, which looks kind of like a U with a little bit of a tail on the side. That's another Greek letter, right? Doesn't just have to be English letters. We'll primarily be sticking to, English alphabet letters, A, B, C, so on and so forth, up to Z. But sometimes there might be Greek letters thrown in the mix, or other letters thrown in the mix, right? You can use any letter. It doesn't have to be an English letter, right? So we can use different letters as we choose. Next, an algebraic expression is a mathematical, it's a mathematical statement consisting of constants, variables, and or operations. Maybe an example could be 3 plus 2. That's a pretty simple expression, right? Maybe another example is 7x squared minus 3x plus 4. That's another expression. A little more complicated expression, but still an expression, right? Or maybe we have 3 parentheses 4 squared minus negative 3 close parentheses plus 6. That could be another expression, right? It's got constants, maybe it's got some variables, maybe it's got some operations. They're just statements consisting of the mathematical terms we have at our disposal, right? They're called expressions. A lot of times we leave the word algebraic off because the context is clear that when we say expression, we're talking about these sort of things, right? Now, terms are multiplicative combinations of constants and or variables. Terms are the things that make up an expression. In this expression here, 7x squared minus 3x plus 4, it has 3 terms. 7x squared is one of the terms. Another term is negative 3x, and the last term is 4. You could have left the negative off of here as well, just 3x, as long as you remember it's subtraction, right? Probably better to write it that way if we're being honest. So the terms are separated by minus and plus. So let's write that. Separated by minus or plus. I always think of terms like words and expressions like sentences. What separates words in a sentence is a space. What separates terms in an expression is plus or minus. Those are some good analogies to help remember it. Next, we have a coefficient. This is the numerical portion of a term, the constant portion. It's the constant portion of a term. For example, 7x squared has 7 as a coefficient. 7 is the numerical part, right? If I wanted to look at 3x, its coefficient would be 3. If I wanted to look at a just plain old number 4, its coefficient would just be plain old 4, right? It's the part without the variables, right? The part that's not the variables. The part that's the numbers, right? Be careful, exponents do not count as coefficients. They're exponents, right? We already have a term for exponents. Like terms are terms with, I abbreviated with, exactly, underline the word exactly the same variable portion. And then under examples, we're going to have some that are like and some that are unlike. So feel free to, put some space out there for each of these. Some like terms examples, 3 and 7 are like terms. They have no variables. Another example of like terms, maybe 4x and negative 2x. They both have x, right? They both have an x. Maybe another example might be 3m squared n and 2m squared n, right? They both have m squared n, exactly the same portion. Unlike terms, on the other hand, are ones that don't have exactly the same portion. Maybe 3 and 3x. Those are unlike. One has x's, one doesn't. Another example might be 2m and 2n. One is m, one is n. M as in Marcus, n maybe as in Nancy, right? They have different variables. And then a last example, maybe we have 4x and 4x squared. X and x squared are not the exact same, so these are unlike. They are not like. So to simplify an expression, the last definition, there's going to be 2 steps. The first step is clear parentheses. If your problem has parentheses in it, you should get rid of them. We saw a chapter ago, in chapter 5, that we can distribute to clear parentheses. That would be a good idea. And then second, we combine like terms by adding and or subtracting coefficients. You combine like terms, and to do that, we need to know what the coefficients are. I think the best way to see how to simplify expressions is with some examples. So let's do some examples. Let's combine some like terms. 3x plus 6x. Those are like terms. They're both x's. What is 3 plus 6? Well, hopefully we all agree it's 9, and I keep the x. The x does not change. Your term will still have the same variable. You're just combining the coefficients. Let's look at the second example. 5y minus 2y. Well, they're both y's, so I do 5 minus 2, which is 3y. Make sure the y does not go away. In our third example, first, I see an x all alone. Remember, there's a hidden 1 out in front of a variable whenever it is not written. You can always assume there's a hidden 1. A single x is the same as 1x, right? Now, I have 1x plus 3. That is not a like term. Minus 8x. That is a like term. So when I go to write my answer, I combine these like terms. What is 1x minus 8x? Be careful of the signage. We're doing 1 minus 8. This plus is on the 3. The minus is on the 8, right? What is 1 minus 8? Well, 1 minus 8 is negative 7x. Now, I move on to my next like terms, and that's the numeric terms, right? I've got a 3 and a 12. It's plus 3 and plus 12. They're both plus. That's going to become plus 15, right? If I add 3 and add 12, that's the same as adding 15. Now, next, in our last example, there's a bunch of like terms, right? There's a bunch of terms all over the place. Let's identify the like ones. Negative 3x and positive 4x over here, right? I've got a plus 2 and a plus 10. Those are my terms without variables. And then I've got a, maybe I'll do a loop for 5y and a loop for 2y. This is a minus 5y, though. Make sure you're aware of the signs out front. So let's go through one at a time. Let's deal with the x's first. Negative 3x and plus 4x. Well, negative 3 and positive 4, when I add them together, right, negative 3 plus 4 is negative 1x. So I dealt with the x's. Some people like to cross them off as they go. That's perfectly fine. Next, maybe I want to deal with the y's. Maybe I want to get all my letters out of the way first, right? I can choose which terms to deal with as I please. Negative 5y and plus 2y. Be careful of the signs. Negative 5 and positive 2, those combine to make negative 3, right? Negative 5 plus 2 is negative 3y. And now I've dealt with the y's. Maybe I cross them off, right? Lastly, 2 and 10, they're both plus. Plus 2 plus 10 would be plus 12, right? So this combines to negative 1x minus 3y plus 12 after I have combined my like terms. Notice I went term by term, right? I combined like term first for the x, then for the y, and then for the constant portions, right? And I cannot simplify any of these problems any further. This is as simplistic as they can become. I have combined all of my like terms. There's nothing else to combine. So make sure you don't go too far, right? Now, order of operations. Let's recall, we already learned the order of operations, but let's real quick write them. First, number 1 is groups. You always work with your grouping symbols first. Number 2 is exponents. Number 3 is multiply and divide. And remember, you go left to right, in case we forgot. And then number 4 is we add or subtract. And same thing, we go left to right as well. And so that's a real quick review of the order of operations, right? Now, we want to use this to evaluate some expressions. So here, to evaluate an expression, the first step is plug in the variables. We plug in any variables, and then step 2, we use order of operations. We use the order of operations second. So we plug in variables, then we use the order of operations. Now, I want to start with the second example first for some vague, mysterious reason, because I think it'll be a little bit clearer than the first example if we start with that one. So let's start here. 2x plus 4y squared for x equals negative 3 and y equals 2. Well, I've got 2. X becomes negative 3. Notice I put parentheses where I replaced the x to hold the number I replaced with. Very good habit to get into. Plus 4. Now we need y. Notice I put parentheses for y again. Squared. Always good idea to put the parentheses when you plug in, because that'll help keep you organized. Now, group symbols first. There's nothing to do inside, so I go to exponents. I've got 2 squared, so I'll have 2 times negative 3 plus 4. 2 squared is 2 times 2, which is 4, right? I did my exponents, now I'm multiplying. 2 times negative 3 is negative 6, plus And I can do the 4 times 4 right now if I wanted to, but we'll leave it separate for now. We still got 4 times 4. Now we've got negative 6 plus 4 times 4. That's 16. And negative 6 plus 16 will give me positive 10, right? Negative 6 plus 16 is positive 10. So that was my first example I wanted to do. Now over here, I want to be careful. What number is hiding between this negative sign and this x that I did not write? I should be careful to make sure I know there's a hidden 1 there, right? There's always a hidden 1 out front if you didn't write it. So I like to put it there because negative 1 x, which is 2, squared, plus 3x, which is 2, plus 10. Notice the use of parentheses to keep myself organized. Be careful with your parentheses. Now, I start with groups, nothing to do inside of them. I move to exponents. I'm going to have negative 1, 2 squared is 4, plus 3 times 2 plus 10. I did my exponents. I moved to multiply and divide. Let's multiply. We got negative 1 times 4, which is negative 4, plus 3 times 2. That's what I do next. Might as well do it now. 6, right? So we did this and this. And then we've got plus 10. Negative 4 plus 6 plus 10. Let's see. Negative 4 plus 6 gives me 2. And add 10 more gives me 12. So I get 12 as my final answer here. Notice these problems don't have a new step except for plugging in. These problems could have been from Chapter 5. The only new thing is we are plugging in variables before we use the order of operations, right? That is the new concept we want to focus on, is using variables, plugging in values. Now, these naturally lead to equations. An equation is a statement that two expressions are equal. It's a statement that two expressions are equal. Equation, equal. They have an equal sign already packed into them. An example might be 3x plus 5 equals 11. This is saying 3x plus 5 equals 11 is a true statement, right? It's saying they're equal. A solution of an equation is a value that makes an equation true for the variables at play, or variable at play. So if I wanted to find a solution to this equation, I would want to find a value for x that makes this true. That's what we want to do, is we want to be able to find solutions for equations. Now, let's take a look here at our next page. We want to look for solutions of equations. Let's see what this would look like. Example, is 2 a solution to 3x squared plus 7x minus 11 equals 15? Well, the way I always check is I plug in 3 times 2 squared plus 7 times 2 minus 11. And I want to know, I usually put an equals with a question mark next to it. I don't know if it's equal yet. I want to know if that's the same as 15, right? I'm trying to check. Here I do exponents first, right? Exponents are always first. Well, group symbols are first, but I didn't have any to worry about. Minus 11. I still don't know if that's equal to 15, right? Now I multiply. 3 times 4 is 12, and 7 times 2 is 14, minus 11. Is that equal to 15? What is 12 plus 14 is 26 minus 11 equals 15? Yeah, this tells me that 15 is indeed equal to 15. So I know, yes, 2 is a solution. 2 works for this problem. So I know 2 is a solution to this equation. 2 works. I know that. It just showed me that, right? Now, How would I find 2? Here it gave me the number 2 and asked me to check it. Usually, we will be given an equation and we want to find the number that makes it true. So let's take a look at addition and subtraction properties of equality. So, addition and subtraction. What are these properties? This says we can add or subtract the same value from both sides of an equation. We can add or subtract the same value from both sides of an equation. That's the addition and subtraction property of equality. The multiplication property of equality says we can multiply both sides of an equation by the same non-zero value. We can multiply both sides of an equation by the same non-zero value. That's the multiplication property of equality. The division property of equality says we can divide both sides of an equation by the same non-zero value, by the same non-zero value. You can't use 0 for either of these last two properties. It has to be something besides 0. So just be aware of that. So we can add, subtract, multiply, and divide both sides of an equation by the same thing. Think of it as keeping it balanced. If you do something to one side of an equation, you have to do the same thing to the other side. And we'll use these for our procedure in solving linear equations. The first step for solving equations is clear parentheses. We want to get rid of any parentheses that might show up in our problem. Get rid of those parentheses. Very first step. Step 2 is clear fractions by multiplying each term in the equation by the common denominator. And I'm going to abbreviate denominator denom. And I'm going to put a star because this step might sound weird until you see it. You want to clear fractions by multiplying each term in the equation by the common denominator. So I'm going to star that one because we'll be talking about that one in specific in a moment. See if we look ahead. It's right here. We'll be looking at it, right? So let's write number 3. For step 3, we use the add or subtract property to get the variables on one side and the constants on the other. So we use the add or subtract property to get the variables on one side and the constants on the other. Here's where we start shuffling stuff around to get all the variables on one side and all the constants on the other side. Step 4 is use the multiplication or division, I abbreviate it, right? Multiplication and division properties to isolate the variable. Here's the step where we're actually getting an answer. You're isolating the variable and finding out what value is true. And then step 5 is check. Always check your answer. Always check your answer. That's always your last step, is check that your answer makes sense. So this is our procedure. Let's see it in action. It may be helpful for you taking notes to make sure you can still see this page while I'm talking. I'm going to set it off camera, but I'm still going to be looking at it, so I can talk out loud about the steps. Let's look at our first equation. 3x minus 5 equals 28. I'm going to rewrite it. 3x minus 5 equals 28. And then some people find it helpful to draw a dotted line down the middle of the equal sign, because now you know if you do something on the left of the dotted line, you have to do the same thing on the right. Step 1, I want to clear my parentheses. Boom, I'm done. There were none. Step 2 is clear fractions. Boom, I'm done. There were none. Step 3 is use the add or subtract property to get the variables on one side and the constants on the other. There's only one variable term, and it's right here, already here. So what I want to do is get all the constants on the other side. I need to get rid of this minus 5. What's the opposite of minus 5? Well, that's plus 5, right? That will cancel it out on that side. Plus 5 will cancel it right there. But I have to put a plus 5 on the other side. If you put a plus 5 on one, you got to put a plus 5 on the other. That leaves me with 3x over here equals 28 plus 5 is 33, right? Now, I got my variable terms here and my constant terms here. Now, I'm ready to get rid and move on to step 4. I'm ready to find my answer. I have 3 times x here. What's the opposite of multiplication? That's division. So I'll use the division property to get rid of that 3. I'll divide both sides by 3. And if I do it to that side, I have to divide this side by 3 as well. That'll give me x equals 33 divided by 3 is 11, right? So I think x equals 11 is my answer. I should check really quick. So to check, I plug in 3x is 11 minus 5. I multiply, gives me 33 minus 5 gives me 28. Notice I just did a little scratch work, right? 3 times x minus 5, I plugged in and I worked it out and I got 28. I know it worked. So I know my answer is correct. The checking step doesn't need to be rigorous. It can be scratch work. Just make sure you're checking your answer makes sense. These are the only problems we have encountered so far where when you leave the problem, you should always know you got it right, because you can always check that your answer is correct. So let's take a look at our next one. I'm going to draw a dashed line down the middle again. Step 1 is clear parentheses. There were none on the left, so I'll copy that down. 6t plus 11. Over here, I'll distribute the 2, and I'll have 2t plus 12 minus 5, right? Now I noticed something. I've got plus 12 and minus 5. These are like terms, aren't they? I could combine them if I wanted to, so let's do that. Let's rewrite 6t plus 11 equals 2t plus 12 and minus 5 make plus 7, right? So I cleaned things up a little bit. You should always clean things up when you see the opportunity to do so. That's true in both math and real life, right? Like you see some garbage on the side of the road and you're walking, pick it up, right? Toss it in the trash can if you can, right? Always good to be a conscientious citizen. So 6t plus 11 equals 2t plus 7. I'm now ready to start moving things around in my equation. I've got variables here and here. I want to get them all on the same side. Well, I'm going to move this 2t. The opposite of positive 2t is negative 2t, right? And if I put it there, I need to put it on the left side as well. Remember, if you do a thing to one side of an equation, you got to do the same to the other. That'll cancel these two out. 6t minus 2t gives me 4t plus 11 equals, and I have a 7 left over, right? I've got all my variables over here. Now I got to deal with the 11. Let's subtract 11 from both sides. So here I subtract 11. That leaves me with, pardon the use of space, but that leaves me with 4t over here. 7 minus 11 is equal to negative 4, right? So we now have all the variables on the left and all the constant terms on the right. I'm now ready to divide. 4 times t, the opposite of times is divide. So I'll divide both sides by 4, which gives me t equals negative 4 divided by positive 4 is negative 1. So I think my answer is negative 1. Now I should check. Maybe I want to check, quickly in my head. 6 times negative 1 is negative 6 plus 11 is 5. So I got 5 when I plugged in on the left. Negative 1 gives me 5 on the left. If we wrote it out, 6 times negative 1 plus 11 is negative 6 plus 11 is 5, right? Do a little bit of scratch work. Let's check the other side. Let's see. Plug in negative 1. I do the parentheses, negative 1 plus 6. Let's write it. Negative 1 plus 6, and then I got a minus 5 on the end. Negative 1 plus 6 is positive 5. 2 times 5 is 10. Minus 5 is 5. Notice I'm just going quick for the check, right? Because the check is just for me to know I have the answer correct. The answer is t equals negative 1. The check, I got 5 on the left and 5 on the right. I know this is the solution, right? I know that's the solution. Now, let's look at our first example with fractions. Let's rewrite it. We have 2/3 x plus 1/3 equals 3/4. Now, I'm going to use the trick I mentioned on the previous page. I'm going to get rid of all the fractions in one step so I don't have to deal with them for the rest of the problem. And to do that, I'm going to write 2/3, 1/3, and 3/4 on the margin of my paper. And I'm going to multiply them by something over 1. What would a common denominator between 3, 3, and 4 be? Those are my denominators, right? Well, it would be 12, right? So I'm going to multiply them by 12 over 1 because this will give me 24 over 3. The second one will give me 12 over 3. And the last one would give me 36 over 4, right? When I multiply each one by 12 over 1. Now notice what happens. What's 24 divided by 3 is 8. 12 divided by 3 is 4. 36 divided by 4 is 9. These numbers here will replace the original numbers in my equation. 8 will replace 2/3. 1/3 will be replaced by 4. And 3/4 will be replaced by 9. This equation here will have the same answer as the original problem. But now I don't have to work with fractions throughout the problem. I have cleared them. I did some trickery. I multiplied everything by 12. Everything. Now, if there was a whole number in this as well, let's say hypothetically on the end here was plus 7, you'd also multiply 7 times 12 over here and replace it by 84, right? 7 times 12 is 84. You have to multiply everything by the number, not just the fractions, all of the terms. So if you have a whole number term, make sure you multiply it as well. Now, no parentheses to work with, so we'll start subtracting from both sides. I want to move that 4 over, so I'll subtract 4 from both sides, right? That'll leave me with 8x here, because those will cancel, and 9 minus 4 will give me 5. To get x alone, I need to divide out that 8, which will give me x equals 5/8, which is what I think the answer is. Now, if I wanted to check it, the right side is 3/4, so let's look at the left. We've got 2/3 times 5/8 plus 1/3, 10 over 24, right? 10 over 24 plus 1/3, I multiplied. Let's see, I can get common denominators of 24, multiply this by 8 and this by 8 will be 8 over 24. When I add those together, I get 18 over 24, which is 3/4 when I reduce it, right? So I checked my answer really quick in my margin. Remember, the check is so I know for sure the answer is correct. That is what the check is for. Now, our last example, we've got some decimals thrown into the mix, some decimal numbers. 4x minus 0.48 equals 0.8x plus 4. Now, the first thing I always like to do is get all of my variables on one side. 0.8x. I want to move that to the left. Maybe we put our dotted line here. I am going to subtract 0.8x from both sides, which means I'll subtract 0.8x. Now, how do I know what number is 4x minus 0.8? Well, if I use my calculator and do 4 minus 0.8, I get 3.2, right? So I'll put 3.2x here, minus 0.48. These ones canceled out. I'm left with plain old 4 on that side. Now I got to move the 0.48. I'll add 0.48 to both sides, add 0.48, gives me 3.2x equals 4.48. Now I'm ready to divide. Once again, you divide by the coefficient in front of the x. This tells me to do 3.2 times x. The opposite of times is divide. Divide one side, got to divide the other. This is going to tell me that I'm left with x equals 4.48 divided by 3.2 is equal to 1.4. So I think 1.4 is my answer. I should go back and check. Maybe this time let's check with the calculator. 4x, 4 times 1.4 equals, take away 0.48, take away 0.48. I got 5.12. I'm going to remember 5.12 and I'll work on the right. 0.8 times 1.4 plus 4, 5.12. I got the same thing on both the left and the right, so I know I'm correct. I know my answer is correct. Notice I checked quickly to know the answer was correct. And that's our first examples. The next two and the last two for today are going to be a little bit different. First, let's look at them. They look a little bit cumbersome, so let's draw a dotted line down the middle. And let's do our first step of clearing parentheses. We distribute, right? 3, and we'll have to distribute over here a 2, right? 3x minus 15 plus, I'm going to write 1x plus 12 equals 6x, distribute the negative 2, gives me negative 2x minus 4, right? Got to be careful, minus and plus make a minus, right? So I got 3x minus 15 plus 1x plus 12 equals 6x minus 2x minus 4. If I look at the left side, I've got some like terms here. I've got 3x and 1x. Those combine to be 4x. I've also got negative 15 and positive 12. Those combine to be minus 3, right? I'm cleaning up some like terms before I start moving stuff around. I'm just looking at the left. Now, same thing on the right. 6x minus 2x, that's 4x, right? And then minus 4, that's not a like term, so I can't combine it. So I've got 4x minus 3 equals 4x minus 4. Now we want to get all of our x terms on one side. I've got 4x here, so I can subtract 4x from it. But if you do it to the right, you have to do it to the left. Now on the right, they cancel out, don't they? 4x minus 4x cancels out. That happens on the left too, doesn't it? 4x minus 4x. We cancel out. And I'm left with negative 3 equals negative 4. That doesn't make sense. Notice the variable disappeared all of a sudden, right? That can happen. Sometimes you might have the same amount of variable on each side. This statement here, does negative 3 equal negative 4? No, that's false, right? That is a false statement. What this means is there is no solution. No number you choose will ever make this problem true. Nothing you ever plug in will ever work out. It is an impossible to solve equation. Notice the variable disappeared and we were left with a false statement. That was why it was a special example. Some equations have no answers. Now, let's look on the right at our other special example and then compare and contrast with that first one. Once again, we've got parentheses, so we'll distribute. We got to distribute a 2, and we have to distribute a negative 3, right? It gives me 2x plus 8, gives me negative 3x plus 15, which is supposed to equal negative. I'm going to put this 1 in here for now as a placeholder, right? It's always there if it's not written. So I distributed, right? I distributed here and I distributed here. Now, if I look at the left, I've got some like terms, right? I can clean up. 2x and minus 3x. 2 minus 3 is negative 1x. Plus 8 and plus 15 is plus 23. Which, weirdly enough, is exactly what was here. So if I try and move stuff around, let's see, I want to add 1x to cancel this out. Well, I'm going to have to add 1x on this side, right? If I did it to the right side, I got to do it to the left. So that'll cancel that out, and it leaves me with 23 equals 23. Once again, the variable disappeared, didn't it? But now, is 23 equal to 23? That's true, right? What this means is all real numbers are solutions. Every number in the world will work. You plug in 2, it'll work. You plug in negative 3 million, it'll work. You plug in pi, it'll work. Any number you plug in will solve this equation. It has every number as its solution. Every number will work out. This has infinitely many solutions, whereas this had no solutions. These each had one solution. So those are the possibilities for our equations. They either have one solution, the most common, no solution, or infinitely many solutions. All three are possible. In those last two cases of no solution or everything's a solution, notice the variable disappears out of both. And the only difference is what's left false or is what's left true? And that is the key between no solution and all real numbers are solutions. So make sure you're aware of each of these possibilities. They don't happen a lot, but they do happen. Some equations have no solution, and some have everything as a solution. But most of the time, there'll be exactly one answer, right? And that brings us to the end of section 6.1. Thanks for stopping by, and I will see you next time.